Okay, so in this video I'm going to prove that for all integers a and b, for all integers, minus a times minus b is plus ab. So in other words, we're going to multiply two negatives here and we're going to end up with a positive. So similar to the previous proof that I did, I'm going to start with the distributive property. I'm going to start with this here. I'm going to write that down. And we've got a minus a times minus b, so I'm going to write down here minus a plus b. So we can see we've got a minus a here, a minus a here, multiplied by the integers minus b and plus b. So I can rewrite that as minus a times minus b plus b. Working backwards using the distributive property, that times that, minus a times minus b will give me this bit here. Minus a times plus b will give me this term here. And we're going to add the two of them together here. That's where this plus sign comes from. Okay, so let's start then. We can see again here, it's very similar to the previous proof. We've got a minus b plus b here. So they are obviously additive inverses of each other. So all we're going to get there is 0. So this is the additive inverse property. Okay, so that's the second line then, so let's move on to the next line. So what we've ended up with here again is minus a times minus b plus minus a times plus b will just give us 0 here. 0 times minus a is just going to be 0. Okay, so again we have two terms here added together and our answer is 0. So that would mean that both of these must be additive inverses of each other. Whenever you add two integers together and you get 0 as your answer, both of them must be additive inverses. Remember, this is an integer and this is an integer here. Because we're multiplying two integers, remember this is the closure property. A is an integer, b is an integer. When you multiply two integers, your answer will also be an integer by the closure property. So all of this here is an integer. We're adding it to this integer here, and we're getting 0. So both of these are additive inverses of each other. So in other words, let's write that down. We've got therefore minus a times minus b is the additive inverse of minus a times plus b. So these two here are additive inverses of each other. Okay, but again, if we take the second one here, that's minus a times b. That's just minus ab. That has additive inverse. That has additive inverse of AB. The additive inverse of minus AB is plus AB. So again, if minus A minus B is the additive inverse of minus A plus B, and the additive inverse of minus A plus B is AB, then this here must be equal to this here. If this is the additive inverse of this, and this is the additive inverse of this, then these two here must be equal. So we'll just write that down. Therefore, minus A times minus B is equal to AB, which is exactly what we wanted to prove. This is our original statement that we wanted to prove. So basically, if this is, if you like, if this is the opposite to this, if one thing is the opposite to another thing, let's say x is the opposite to y, and y is the opposite to z, really you're going back here again. X must be equal to z. This is maybe one way of looking at it. Okay, so that's our second proof using the properties of integers.